Hello again, grade 8s. In today's lesson, we are going to look at calculating the surface area of our final three-dimensional object, and that is going to be for a right cylinder. Our learning outcome is to determine the surface area of right cylinders to solve problems. Let's begin by defining what a right cylinder is. So it's got that can type shape to it. A right cylinder consists of three faces, where two of those faces we're going to call bases, and the two bases of the right cylinder are congruent circles, or you can refer to them as being caps. So I'll just sketch in what these caps would look like. So you have like a circular cap at the very bottom, and you have a circular cap at the very top. They're congruent circles because they have the exact same shape, the exact same size, and they're parallel because every part of the caps are the same distance apart. You also have, well, let's label the caps there. Okay, so you got the cap at the top, and you got a cap at the bottom. You also have a curved segment as the third face. So I'm just going to erase the what I've sketched in for the caps here, and let's just illustrate what the curved segment looks like. So the curved segment would be like where you put like a label on like a can or something along those lines. So your curved segment goes all the way around, and it's going to be between the two caps, and that's going to be my third face. So this curved segment of the right cylinder. It turns out that if you take that curved segment and you remove it from, like, again, think of this like having like a paper label around like the outside of the can as your curved segment. If you were to take that label and make a little cut and then unfold it, it turns out that that curved segment actually unfolds into a rectangle. So what I mean by this is, here, I'll just erase this. So if you had like this cap, or you had this label, and you made a cut right here along the label, and then you unfolded that label, it would actually unfold to give you a rectangle. The easiest way to identify this is just to look at what the net for the cylinder would be. So one example of a net would be if you just take the two caps and you unfold them. So you take the top cap and fold it upward, you take the bottom cap and fold it downward, and you make that cut here, and then you unfold like the curved segment. The curved segment does unfold to give you a rectangle. Now, it turns out that the length of one side of the rectangle is actually the circumference of the circle. And just to refresh your memory, back in the first lesson of this unit, we reviewed some important information from circles from grade 7. The circumference of a circle is equal to pi multiplied by the diameter. So let me just illustrate this. So I'm going to take, so if we take the top cap and we look at the circumference is like the distance around the circle, the outside of the circle one time, or its perimeter. So if you were to take this circumference and you were to make this cut and unfold the curved segment, this circumference here, C, would end up being equal to this length all the way across. Okay, so we're going to have to do a circumference calculation when we determine the surface area of the cylinder. And the other side is just the height of the cylinder. So the vertical height of the cylinder from the bottom cap to the top cap is h, little h. Then that would equate to this side length on the cylinder. And again, if you'd like, I can just illustrate that. So we take, let's do it in green. No, let's do it in purple. Okay, we take this side length, which is the height of the cylinder, and we unfold that label. It would be equivalent to this length right here. Therefore, again, right cylinder has three faces. You got the two caps, and you got that curved segment that you can unfold into a rectangle. First example, we want to calculate the surface area of the following cylinder. And then again, just like in the previous problems, we were figuring out surface area of those shapes. We need to draw each distinct face, label the dimensions, and then also calculate the area of each face before we put everything together and we determine the total surface area. Now, before I start, I'm just going to write down some equations that we're going to need to use to deal with these problems. So again, this all goes back to the first lesson of this unit. So the diameter of a circle is 2 times the radius. The radius of a circle is the diameter divided by 2. The circumference of a circle is pi times the diameter. And the area of a circle is equal to pi times r squared. So let's start off by drawing the caps, okay? So we'll do the top cap and we'll do the bottom cap. Okay, so I'll just sketch what the circle looks like. Draw the center of the circle. Okay, now you have to identify which piece of information is being illustrated in the diagram. So in the diagram, it's showing the distance from the center of the circle to one of the outside edges. That's your radius, okay? So your radius, let's do this in a different color. Your radius will be equal to 2.5, in this situation, meters. Okay, so it's actually set up to figure, since we have the radius, we're actually set up to calculate the area of the circle. So the area of the circle, so we'll say AC for the circle. Actually, let's write down A cap. Okay, so we've got A cap is equal to pi times r squared. And again, if you have that r squared, it just means repeated multiplication of the r. So that's going to be pi times r times r. So the area of the cap would then be equal to, we're going to use the value of 3.14 for pi. If you use the pi button in your calculator, it's going to get something a little bit different. So 3.14 times r, which is 2.5 meters, multiplied by 2.5 meters, and we get the area of the cap is going to be equal to, so we have 3.14 times 2.5 times 2.5, which is 19.625 meters squared. And this cap repeats twice. Now let's go to this curved segment. So I'm just going to erase these shaded in portions. Okay, so the curved segment is going to be this label that if we unfold it is going to turn into a rectangle. So if we unfold this, I'll say curved portion or curved segment. Now, before I even draw the picture, with the curved segment, I'm going to need to know what the circumference is. So actually, let's just draw the dimensions and we can do the work for it. Okay, so let's draw the curved segments. The curved segment would be, if you unfold a label, it'll be a rectangle that has quite a large length to it. This dimension is the circumference of the circle, which we don't know yet. Okay, we're going to calculate it in a moment. And then this dimension is the height of the cylinder, which we do know it's 5.5 meters. Okay, now if we look up at the equation here, to calculate the circumference, we need to know what the diameter is. So first things first, we have to find the diameter. So the diameter is equal to 2 times r. So the diameter would be equal to 2 times the radius, which is 2.5 meters. So 2 times 2.5 is just going to be 5. So you'd have diameter is equal to 5 meters. And then the circumference. And again, just to illustrate this, just to kind of show what's going on. So again, the circumference of the circle is the distance around the circle one time. If you unfold the label, that's equal to this side length. Okay, now that we have the diameter, we can calculate the circumference. The circumference is pi times the diameter. So that would be circumference is pi, which is 3.14, multiplied by the diameter, which is 5 meters. And then I'd have my circumference is 3.14 multiplied by 5, which is 15.7 meters. Okay, we can actually label this on the picture now. We can say it's 15.7 meters. To figure out the area of a rectangle, just go length times the width. So the length is the circumference. So we just have the area would then be equal to the length, which is 15.7 centimeters or 15.7 meters, multiplied by 5.5 meters. And then I would get my area. Actually, let's write down A curved. A curved is equal to, and we'll write down A curved is 86.35 meters squared. Let's just double check to make sure that's correct. So 15.7 times 5.5, 86.35. And this curved segment, you only have one label, so just once. Now to find the total surface area would be 2 times the area of the caps. Because you've got 2 caps, plus the area of the label or the curved segment. So this would be 2 times the area of the caps, which is 19.625 square meters, plus the area of the curved segment, which is 86.35 meters squared. So you have your surface area is 2 times 19.625 is 39.25. So 39.25 square meters plus 86.35 square meters. And that's going to give me my total surface area of the cylinder would be 39.25 plus 86.35 gives me 125.6 square meters. And we'll box that answer. Okay, on to the next one. It says a stool is modeled in the shape of a right cylinder, as shown in the diagram below. A person wants to cover the stool with material where the bottom of the stool does not need material. Okay, so what that means is if the bottom of the stool does not need material, we're not going to calculate the surface area of that portion since we're not going to put any material in that part of the cylinder. Okay, so let's determine the amount of cylinder material required, which is just going to be the surface area. All right, so we start off by drawing so I'll start off with the cap. Now, we're only going to take the top cap here, okay, because we're going to put material along the top cap and along the curve segment. So your cap, let's just draw the circle. Now, this time around, what it's showing is it's showing the distance from one side to the other, passing through the center. That's the diameter of the circle. Okay, so it's going to be a bit different in how we have to solve the problem. Okay, so this is your diameter, which is equal to 42 centimeters. Now to calculate the area of a circle is pi times r squared, but since we have the diameter, we have to calculate the radius first. So I'm going to write down radius is diameter divided by 2. Radius would be 42 centimeters divided by 2. And your radius is then going to be 21 centimeters. Then to calculate the area of the circle, so the area of a circle is pi r squared. And again, that r squared is the same thing as going pi times r times r. And let's write down a cap here. So then the area of the cap is equal to 3.14 multiplied by r, which is 21 centimeters, multiplied by r again. Those are 21 centimeters. And then I get the area of the cap would be 3.14 times 21 is 1384.74 square centimeters. Okay, that's the cap. Now we're only going to do this one time, okay? Because we're not covering the bottom of the cylinder or the bottom of the stool with material, so it's just going to be times 1 here. Okay, now the curve segment. Okay, so if we make a cut along the label and unfold it, it's going to be a really long rectangle. So let's start the rectangle here. Go over like that. Okay, so the height of the rectangle, I can see in the picture, is 32 centimeters. And then the circumference of the circle, if you unfold the label, is going to be this, this bottom length. So I don't like how I drew that. Circumference of the circle is this bottom length here. Now, I can actually calculate the circumference right away because I already know what the diameter is. So I can say circumference is equal to pi multiplied by the diameter. So circumference would be 3.14 multiplied by the diameter, which is 42 centimeters. And then 3.14 times 42 is 131.88. So 131.88, and the units are centimeters. Now that I have this bottom length, the area of the rectangle, and this just repeats one time, is just going to be length times width. So that's going to be the area of the curved segment would be equal to the length, which is 131.88 centimeters multiplied by 32 centimeters. And the area of the curved segment is going to be 138 times 32, which would be 4,220.16, and the units are square centimeters. And then now your total surface area is just going to be the area of the top of the stool. So that's the area of the top cap. Again, we're not including the bottom cap because we're not covering the bottom of the stool with material, plus the area of the curve segment. The surface area would be 1384.74 centimeters squared plus 4,220.16 square centimeters. And then you'd have your surface area if you add these two numbers together. So 1384.74 plus 4,220.16. And that's going to be 5,604.16 9, and the units are square centimeters. So this actually marks the end of the first half of the first part of the unit. So the first part of this unit on surface area and volume is dealing with uh, looking at the views of 3D objects, looking at the nets, and doing surface area calculations. And then we transition into part 2. It's going to be all about calculating the volume of actually the exact same shapes: the right rectangular prism, the right triangular prism, and the right cylinder. In the meantime, you can practice this by completing in your surface area and volume workbook, surface area of right cylinders, and I'll talk to you in the next lesson.